Okay, class, let's go ahead and get started. Today we're going to work through our React app, and we're going to hook it up to a Docker file, a Docker Compose database instance, get an API project set up, and talk about getting it deployed to AWS. Real quick, I'm just going to show you a project that I've been working on for a client. So this is typically how I'm going to break down a project that I'm making. So this is a full C# Blazor project. Blazor is Microsoft's version of React, basically, is all it comes down to. So we'll just kind of talk about this real quick. We have infrastructure, and this is what I use to deploy to AWS. And the language that we use is called Terraform. And so you can see in Terraform we build different modules, and each one of these modules points to an AWS service. So we have EC2, which are like the virtualization machines that AWS offers. And so we can come in here and we can take a look at this, and it's like a strange version of JSON. It's their own language called Terraform, and we can just talk through this real quick, and I can kind of show you what it does. So this is just declaring what type of instance we're going to use, and I use Ubuntu when we're on AWS. It's the cheapest. So if I were going to do it the easy way, I could just spin up a Microsoft server and deploy all of my Microsoft stuff in IIS, which is Microsoft's Information Internet Service, something like that. But for cost comparison, that's like $300 a month if you want the full Microsoft stack. You can deploy a Linux-based app with Postgres for $50. If you don't want to use RDS, which is their relational database service, you can get away with doing it for $50 a month, maybe a little less, like $40. And what that involves is having a Dockerized solution, a container here that has your database in it. The drawback to that and why I can't use this is a production ready. This is going into deployment, is going to be an actual website that people use. And the reason I don't use a Dockerized Postgres, I'll use it for development, but I won't use it for production, is then I have to manually manage backups. I have to manually handle all sorts of things that having RDS takes care of for you. So the Terraform, we just come in, and in a main TF, we declare our variables. So we're saying it's going to be the most recent version of Ubuntu. We tell it what image we're going to use. We tell it its virtualization type. And then you have to create a key pair. And you'll just notice variables here. They're passed from our variable file here, which then actually gets defined within our environment. So we could have different development and different production environments. For this project, I did all of my development locally. So I could just deploy it here using a Dockerized database of Postgres. So I didn't have to have a dev environment, and that was also a cost savings thing, because then you have to pay the additional $50, $70, whatever a month to have your dev instance separated from your production instance. You know, I'm a one-man shop on this, so didn't make sense. I'm trying to make as much profit as possible. So we came in here, and looking at our EC2, we can see we then define our instance, and we just pass these variables and the key names to it and some data and everything like that. So we have a user database shell script, and that's what's going to define how this is going to run as soon as the EC instance is set up. And what I use this for is actually to set up something called NGIX, which is the routing. And it's basically what tells it to say this.com routes to this IP address that we're going to get from Elastic. And so this script comes in, defines what to do when it starts up. So it starts up my API service, and then it starts up my app service, which is the front end UI. Just a whole bunch of Terraform, this is a whole bunch of a shell script that gets run by the Terraform, and I'll show you where that gets called. So this is setting up the proxy for NGIX, all of this sort of information, same thing, and then we just send some package information, the environment, you know, just basic stuff for a setup. And so all of that comes into an output, and the output file lets us send it over here to our production environment that picks it up from the main. So then you can see we have something very similar for RDS. We're saying, okay, well, we need subnets because I need to have my app be able to connect to my database, and so I'll need an IP address that it can hit my database with, takes in a password, everything like that, and then we also define that it's going to be a Postgres. We use Postgres because it's an open source database solution. It's not quite as robust as Microsoft SQL Server. It uses this tool pgadmin 4, so I can go ahead and bring that up. I typically access all my database stuff through Writer. You can do this with Visual Studio Code as well, but here you can see it built builds the database, and we have the information. And so I have a local. So when you install Postgres, that means it's local on your machine. Then it's separate. There's Docker, and we'll get into Docker in a little bit. But then you can see we have the tables that get sent out there. So for me, identity is Microsoft Identity, which is like their login management, user creation stuff. And then there's some public information that I haven't generated any of the tables here or to production. So I can see my 3 different databases here. So Dockers can be easily deleted, removed. With the local version, it's a little bit more different. I prefer to use the Docker version, but the co-developer I have on this with me prefers to do everything locally, so we have to have an instance to handle both. So Route 53 is their DNS service, and so that just means that it maps the IP address to the domain name that you have. So you register your domain name in Route 53, and then you just come in and set up a record and say, okay, well, my EC2 instance, which is my Ubuntu, points to this public IP address that we're going to set also in this Terraform. And so that's all set through the VPC. And so the VPC comes in and sets our local addresses and sets up a private net gateway and a public route and all of the stuff we need for all of the information to communicate between each other. We'll go ahead, pause the video. I'll log into my AWS and I'll just kind of show you what that looks like in the console. Okay, I logged in with my user email, had to do my multi-factor authentication. So this Amazon instance is set up specifically for this app. You can see the cost breakdown here. Registrar is me registering domain names. So each domain was $14, so I had to pay for that. But then my actual costs come down here. You can see the cost of me running the relational database service so far this month, 8 days into this month, has been $5.93. Route 53, which is the domain records, has been this much. This is the VPC, the virtual private cloud, all of that stuff. So Amazon's really difficult to navigate until you know what you're looking for. It's all this different collection of a whole bunch of stuff. So you have IAM. So the first thing that I would have to do for the Terraform, and everything that I did in Terraform you can do from the console here. The benefit of doing it in Terraform is now I can just take all of this code and move it to a whole nother project and deploy it to AWS like that without missing any configuration. So I know everything is configured exactly how I expect from that code, and it just deploys to me through Terraform to AWS. And so I just have a user here. Terraform user has an access key. It gets policies through IAM. It's just their access management, identity access management. And so you can see all of the different permissions and stuff. And then I went and created, a giant script of all of the permissions that this user needs to have in order to do what it needs to do, and the services it needs to be able to access to create this. And that allows separation of concerns of principles. So I'm not using my main user to create all of this information. I have a separate Terraform user that I've created within this billing cycle, within this billing structure, that can deploy this app and this code for me to whatever instance I want. So S3 is storage, and for here it's just going to save the Terraform state. So when I come in here and I look at my console and I open my infrastructure, my prod, it already did. We have a couple of Terraform different commands. So we have Terraform init, which is going to initialize it, and what that does is actually then goes and talks to my backend. HashiCorp is the name of the corporation that made the Terraform language, and so I just tell it to create this S3 bucket, and it saves its state. And the reason that's important is because if I come in and change something, I can then run Terraform plan, and it's going to tell me what has changed between what I have deployed and the code that I've made. And so you can see here now I have one change that was made that it wants to push out, and so I'm going to go ahead and apply those actions, and we'll just say Terraform apply, and it's going to say, okay, well, here's what you got that applies for Terraform. So let's go ahead and read all of this. You have to say yes to deploy it, and what it's going to do is it's going to change my EC2 instance because the user data has changed, the user data script, and so yes, I want to apply these changes. And it's going to go ahead, it's going to run, and it's going to create a new version of an EC2 instance for me, running this new version of the user dash that I have created, the user data that I've created, spin up that NGIX and all of that stuff. So this is going to run, and so it manages that state through this S3 bucket. So it pings it and says, oh, has any of it does a delta comparison, says, has anything changed any of this? It has, okay, we need to redeploy it. So it's going to deploy a new EC2 instance. So I could come in here, I could launch my own EC2 instance without using Terraform, and these are the different images that they give you. Amazon Linux, just tough to work with. It's newest. It's, for me, I struggled. I originally tried to do this program with Linux, with Amazon Linux 3 2023. I couldn't even get shelled into the console. I just don't feel like it is production ready at this point. I would much rather go with Ubuntu or Windows. Obviously, we can look and see. Yep, that's fine. We can see price comparison if we go to the AWS price tool. Let's just do AWS EC2 pricing. So we can go into the calculator, and it'll tell us what we want to do. So when we look at Linux, we can see that its on-demand hourly rate is that, but then as soon as we switch it to something like Windows, with SQL Standard would be the huge jump in price. And this is an hourly rate. So, you're looking at 4 cents an hour versus 72 cents an hour. And that's because they have to pay, even less than, it's half a cent per hour. And that's because they have to pay the Microsoft licensing fees. So the benefit of doing it, if you were going to try and do your own Microsoft thing, you then have to buy a Microsoft license for their server and a Microsoft license for SQL Server. With Linux, obviously, you don't have to do that. But with AWS, that's included in the price here. So this is the cost of the service and the cost of the license. If I didn't have to worry about money, if I were a big shop, if I had 5+ developers working on this project, for the ease case, because Microsoft makes it so much easier, I would do Microsoft. But because it's just me, like I said, I'm trying to squeeze out every bit of profit that I can. It's worth it to me to kind of rough through a little bit of the harder coding to get a Linux Ubuntu instance. So I'll go ahead and just wait for the Terraform to finish applying here. So it finished. The other thing that it has that's part of that VPC is Elastic IP, and that just ensures that my public IP here stays the same. So since I did that, it spun down my web instance. So I would actually have to go back into, and we'll go over that real quick. I'd have to go back into Azure. So Azure is Microsoft's management system, and so this is the project that I'm working on, this BCIS web. And so it hosts, just like GitHub, the files and everything like that, but allows us to do a little bit more managed. So you can see pull requests that I've made and put in, or the other developer on my team that they've done, and just basic management. But what it's really cool is it does pipelines. You can see my last pipeline ran failed, but pipelines are just YAML builds that go and build my application and then actually deploy it to EC2 for me. And so YAML is just this language. And so what's really great about this is I can store my repo. I have pull requests that come in. I don't have any code changes, but I could come here. I could push a code change. It would show up on Azure. I can create a pull request, which kind of looks like this. And so if we go and look at like this one, we can look at the files that were changed and what was changed. And then as soon as this is pushed, it pushes to my pipeline, which runs and then pushes that to my EC2 instance. So that's the CI/CD, continuous integration, continuous deployment that you'll hear talk about. There are other tools you can use besides Azure. You can do it directly from GitHub. Everything that you can do there, you can do here. What's nice is you can also then break down work orders, and you can see what's done within it, and you can assign effort to it. This is called Kanban, and as these are the Kanban boards, and that's part of agile development.